Hi, I'm Jaganmohan from Mlritm. I'm Assistant Professor of Mlritm. Today we are discussing about CSA computer system architectures in decoders and encoders. The what is encoders? Encoders is nothing but it is a encoder is a combinational circuit, digital circuit that converts multiple input signals into a smaller number of output signals. Actually, encoder is nothing but it is a take multiple inputs. It will take multiple inputs and it will give like two power inputs will give means it will give n outputs. Here we need to see uh, input and output relation. It converts 2 power n inputs lines to n output lines. If we are giving n inputs means we are giving eight input lines means we need to calculate 2 power 3 means it means 8. 2 power 3 means 2 power 3 means 8. It will convert 3 outputs multiple combinational circuit. It will in multiple combinational logic circuits, number of multiple logic circuits, it will give few of outputs. And the purpose it is a purpose is the output gives binary code that represents which input a line is active. The basic assumption is in simple encoder only one input is active at a time. At the time only one input is active. In each input we are giving like multiple inputs means like in 2 power n inputs we are giving, and it will convert to the n outputs. In n outputs it will come 3 outputs means in 3 outputs one is active input, one is the active value high. It means one output is highest value 1 and the remaining will be the 0. And the example octal binary encoder, it has 8 input lines. We can see that here 2 power 3 means 8. It will convert to the it will produce 3 output lines. It will call 3-bit binary code, and it is working when of the 8 inputs is active, the encoder generating the corresponding 3-bit binary output. uh, 3-bit output binary output. Encoders are used to reduce number of data lines and make digital system is simpler. In hardware, in CSA means computer system architectures means we need to see the computer inside architecture means it will in motherboard we are having multiple lines, multiple digital logic circuits. It will generate the signal control unit. It will generate the control signals, and control signals pass the data like one place to another place. One place to another place means like receivers, all the units in system, it will get the data, and whatever we are giving the input inside to the data, that will convert to the zeros and ones binary code. And the after executing the output, we get exact output. This process will be generated through the digital line, combinational digital lines. So digital lines is nothing but the data circuits. The data circuits means is nothing but data will be flow on the one place to another place. This called digital logic circuits. And combinational sequential signals also we will call it. And the use is the major use of the encoder is now multiple signals is converted to the n signals. Like 2 power n lines will give means it will convert to the n lines. The simple exam is 2 power n means 2 power 3 means 8. 8 input signals we are giving means it will give the output of 3 in output lines. We'll get the output in 3 lines. In that line also, that 3 lines also, one of the output is high value, high active value 1, remaining will be the 0. And the diagrammatically shown here, this is the encoder, 8 by 3 encoder. Here 8 by 3 is nothing but 8 is the major inputs and the 3 is the outputs. Here we have to see D0 to D7 is the 8 inputs, and the 3 is the outputs XYZ. Here the output signals 1 active means every time 1 will be active. Here first time X is the high value, one high value is there first. After that Y should be the 1, and after Z should be the 1. When the value x value 1 means the same value it will come in the CSA computer system architectures. If it is, it will complement means it will come 0. Complement means complement is denoted by 0, and as the same element 1 is denoted as the same element. If it is x belongs to 1 means it will come the as it is element. If it is other elements y dash and z dash it will come, and the some each and every stage the one output will be high. One output means one of the active high element is there, will be there. Active high means y should be second stage y is the 1 means y got same element y, and x dash y dash x dash z dash will become. And the truth table has denoted here we have to see d7 to d0. We need to do the first d7 d6 d5 d4 d3 d2 d1 d0. The writing purpose is first we need to do the actually we are getting d0 is the highest value. First we need to do the first one. We need to write reverse order like d7 to d0. We need to put the all zeros first. D0 should be the one, that is the one highest active value. After remaining we need to write all the zeros, and the next as it is d1 will be the one and the remaining will be zeros, and the next one the d2 will be the one. Other after next d3 and d4 d5 and d6 d7 will be the one, remaining will be considered as a 0. And this one is the and xyz is the 001. We know already very well about 8421 process. 8124 process. XYZ we need to do the first 0 to 7 we need to calculate the 8421 process. First here 001 means 001 we need to put here the binary value of 1 is equals to 0001, and 2 will be the 010. 010 means we need to substitute here 0 like we need to forget 8. Why? Because here 3 bit only, so that's why we are getting only 4 to 1 process. 4 to 1 process. In 4 to 1 process we need to substitute these values like 010. 010 means it is the binary value is 2. Like that same way we are getting all ones means we are getting 4 to 1. All ones means here we are getting decimal equivalent value 7. So we need to write a truth table like this. After that, truth table explanation is when d0 input is active, the output is 000. D0 is in the first stage of d0 here the signal will be 0. Signal will be 0 means automatically the output will be the 0. The binary code of 3 digits of binary code is 000. And when d1 is input is active, the output is 001. Here d1 is nothing but first logic gate. First logic gate we can see if it is d1 is active means the one binary one is active. In the output the one is active high, and the d2 is high means 010. The d2 input is active means the output is 010. The d2 means nothing but this is the decimal value. Decimal value is nothing but d2. D2 means that will be converted to the binary number 010. Similarly, d0 to d7 produce it corresponding 3-bit binary output. It will produce as 3-bit binary outputs. 3-bit binary output is nothing but in the system computer system architectures we are having default 8421 process will be there. We need to substitute binary code like if it is 000 means 000 means it will become 0 in decimal, and 001 means 00001 means it will come to the decimal equivalent number 1. We need to substitute there like the decimal equivalent number, the decimal number is converted to the binary number. It will be calculated with the binary number means need to come decimal number. Here the implementation of explanation is the output of z is equals to 1 when any of these inputs are active. D1 comma D3 comma D5 comma D7. When output is y equal to 1, when inputs D2, D3, D6, D7 are active, here active is nothing but the element will become 1 value, and the output is x is equals to 1 when inputs D4, D5, D6 comma D7 are active elements, active decimal numbers. The Boolean expression is converted as a D4, D5, D6, D7, and y is equals to D2 plus D3 plus D6 plus D7, and z is equals to D1 plus D3 plus D5 plus D7. These are the active high values. Active high value is nothing but it will become one element. When the active high value is 1 means we need to add the all the decimal equivalent numbers, like D4 is one of the, we need to think like one of the gate. We need to add the all gates like D4, D5 plus D6 plus D7, and we need to draw the logic diagram also for this. Here the diagrammatically represented as here D4, D5, D6, D7. We are addition to the all the logic gates, and D2 plus D3 plus D6 plus D7, and Z is equals to D1 plus D3 plus D5 plus D7. Here we need to write first D0 to D7, and we need to gather form the, this is the OR gate. If it is addition means that is denoted by OR gate. Addition is denoted by OR gate. We need to find the first all the gates we need to connect with the OR gates. Here we need to observe the Boolean expression is D4 plus D5 plus D6 plus D7. We need to connect with the gates. So we need to observe D4 is connected like here, D4, and D5 is connected here like here, and D6 is connected here, and D7 is connected here. Like every gate is connected with the OR gate. Like why we need to take OR gate means here we are having each and every decimal unit we are having plus symbol. Plus means it will become OR gate. Plus means it will become OR gate. So approximately y is equals to D2 plus D3 plus D6 plus D7. That also connected here only. Like we need to see here D2 is connected to here, and D3 is connected here, and D6 is connected here, and D7 is connected here. And almost Z is equals to D1 plus D3 plus D5 plus D7 also connected here only. We need to see here. It is nothing but it is the completely logical expression to the logic diagram to the Boolean expression. We are having 3 Boolean expressions that is merged to the one of the the logic expression, logic diagram. In normal encoder, only one input should be active at a time. In normal encoder, every time one input is active high, one input should be active time, and if more than one input active means the output would become unclear and incorrect. That is nothing but if we are giving 8 signals means that when in 8 signals we are having one input high active value. High active is nothing but it will become 1, remaining will be the 0. At the time the process will be generated, and we are getting output. If it is we are giving 8 inputs means we are getting 3 outputs, and in output also we are getting one of the active high value. If it is suppose we are giving two active values means we are giving 2 input lines once means it will be the invalid state, and it will be the incorrect also. Example, if here D6 and D3 are both are active, the output becomes 111, same as D7 also. And another problem is when all inputs are 0, output is 000, which looks like D0 is active. If it is D0 is, we are giving all the signals will be the 0, the output of the first value also. If it is input is 0 means the output will be the 0 only. This to solve this valued bit v is added. V is equals to 0 is no input active, and v is equals to 1 means at least one input active. V is equals to 0 means if we are giving means input is 0 means we are getting output also 0, and V is equals to win at least one input is active means the output also one of the active input also available here. And priority encoder, the priority encoder gives priority to input when multiple inputs are active. The input with highest priority decides to the output. Example, 4 to 2 priority encoders, 4 inputs and 2 outputs. Here we need to see 4 inputs are converted to the 2 outputs, and the working example is if all inputs are 0, valued bit v is equals to 0, the output is on the no output not is used, and the d3 is highest priority. If d3 is equals to 1, the output is 11, and the d2 is next priority. D2 is the next priority. Output depends on d2 only. If d3 is equals to 0, d1 has lower priority than d2, and d0 has the lowest priority. Output 0 0 only, other if others are 0. Here don't care condition means it input can be 0 or 1 without affecting the output. Don't care condition denoted as a x. We means input can be 0 or 1 without affecting output. Any one will become 0 or 1 will come. And the decoders can be the simple points we need to see here. The decoder is a combinational circuit, and it performs a reverse operation of encoder. Here we had a previous in we are discussing about encoder means it will give the n inputs, 2 power inputs, input signals means it will get n input signals, like 2 power 3 inputs we are giving means here we are getting 3 outputs. It here decoders means that is the reverse of the encoder. Decoder is a combinational circuit, and it performs reverse operation of encoder. It converts n input lines to 2 power n output lines. Here we are giving input n inputs means it will become 2 power n outputs. Suppose we are giving 3 output lines means it will convert to the 2 power 3 means 8 output lines it will convert it. And for each input combination only one output is active. Each repetition in output one active high value will be there. It is used to select one output from many inputs. And the example is 3 to 8 decoder. Here we need to see 3 to 8 decoder has 3 input lines. We need to observe this 3 to 8 3 to 8 decoder has 3 input lines means we are giving 3 input lines and we are getting 8 outputs. Depending on the input binary value, one of the each 8 outputs become active. 8 output lines will be active. The truth table shown here, and the as it is here we need to see xyz 0 0 0 0 0 0 means here nothing but binary number should be 0 0 means binary numbers will be 0. Same like that only 0 0 1 means it will be 1, 0 1 0 means it will be 2, 0 1 1 means it will be 3, 1 double 0 means it will be 4, 1 0 1 means it will be 5, double 1 0 means it will be 6, alt ones means triple 1 means it will be decimal equivalent number will be 7. Here we need to see first we need to write one of the active high value one should be in d0 one output should be active, so that's why we need to write first d0 1, remaining will be 0, and the d1 is one active high, so that's why we need to write 1, remaining all are we need to write zeros. At the same like that d2 will be the 0, and d3 will be the 0, d4 will be the 0, d5 will be the 0, d6 d7 all remaining all will become zeros. The implementation is d0 is high when x is equals to 0, y is equals to 0 and z is equals to 0. Hence d naught is equals to x dash, y dash, z dash. In d naught we are getting d naught 0 input signal we are giving, the output will become 0 only. So in the output will become 0 means we are getting the complement like x dash, y dash, z dash. X dash means it will become 0 and y dash will means it will become 0, z dash will become 0. Similarly, when d1 is equals to x dash, y dash, z dash means z will be the active high value. When z is active high value means it will become 1, so that's why z will be the same element. And similarly, same as it is, d2 will be x dash, y, z dash. Here y1, y value the same, y value same means it will become 1, and x dash, y, z, it will become x dash, y dash, y, z means y value, z value 1, and d4 is equals to x value 1 and y dash, z dash 0, and d5 value is also same like that only. Last we need to see xyz means triple one. The triple one means we need to calculate the binary equivalent number, that will become 7. 7 means d7 is there, so decimal equivalent number 7 means we need to write xyz. And the logic gate is diagrammatically represented here. We need to observe here. First we are x dash, y dash, z dash means the d1 is connected x dash, y dash. We need to see here x dash means the not gate here, not gate also connected, not gate also connected. Not gate means we need to like x dash, we need to connect to x dash. And y means y is connected, y also x, y dash also connected, and z dash also connected. Here x dash, y dash, z dash 3 are connected, and the same diagrammatically represented here. If it is xy d7 is equals to xyz means here, here we need to say d7 xyz means here x is there, x is connected here, and y means y connected here, and z means z connected here. And the here we need to see x y z dash means x y z dash means x y z dash, x y z dash means x is connected here, here connected, and y connected here, separate line connected here, and z dash connected here. Z dash means that is connected to not gate, and x y dash z, x y dash, x y dash z. Here we need to see fifth gate, x is connected here and y dash connected here. Y dash means it is nothing but not gate, and z connected here. As it is same like all the gates connected here only, d1 to d7 the gates connected will be like this. This is the encoders and decoders. Thank you very much.